Welcome to Joey's Pandas tutorial series. In this video, you will learn about multi-level indexes in Pandas. This is where Pandas gets even more powerful and your data becomes lightning fast to explore and analyze. With that in mind, let's start learning multi-level indexes. Alright, I am in my Jupyter lab where I have created a new notebook moments ago in which I have already written the code to create a Pandas data frame from a dictionary called data. So let's run this code. Okay, so we have our data frame printed. This is a small banking data set with loan amounts categorized by a region, year, and bank. Now let's perform our first aggregate operation on this data set. Okay, so what we are going to do, we are going to create a new data frame called grouped. And after the equals to sign, we are going to write df dot groupby. We are using the groupby function. Within the group by function, we are going to pass a list of columns. Now, those columns will be region and year. All right. Now, we are going to make use of the ag function, which is an abbreviation for aggregation, to calculate the sum of the loan amount. So, we'll write dot ag. Within its brackets, we are going to write within curly brackets loan. Actually, it will be loan underscore amount colon. Within single quotes, it will be sum, since we are interested in calculating the sum. So what we are doing here, we are first grouping the data by region and year and summing the loan amounts for each of the unique combinations that we are going to create for region and year. Okay. So let's print this data frame. Let's print this. Let's execute this code block. And there you go. Now, this column over here is not actually the loan underscore amount. It's actually the sum of loan underscore amount for each of these groups. That means 12,000 is the sum of loan amount for East region in the year 2022. Okay. 18,700 is the sum of loan amount for the region East in the year 2023 and so on. Notice how Pandas created a multi-index for us automatically. Region and year become the index levels. The combination of region and year becomes a unique identifier for each row, which is exactly what an index is supposed to be. We'll now learn how to access multi-level index data. To do that, we are going to use lock. Thus, we'll write grouped, which is our data frame, dot lock, and within its square brackets, we'll write within brackets east, comma, 2022. All right. So what do you get here? You get the loan amount for the region East and the year 2022. Now, if you want to see the loan amount for all the years for East region, then you will write grouped dot log and within its square brackets, within normal brackets, we'll write East. All right. If we run this code block, you will get the loan amounts for the years 2022 and 2023 for the East region. A thing to note here is that we used tuples here. You can also access the data using a single key. To do that, we'll write grouped dot log and within square brackets, we'll just write East or it's right west this time. If we run this code block, look at that. We got the loan amounts for the years 2022 and 2023 for the West region. Okay. So what you need to keep in mind is that you can access data using lock with tuples or single keys depending on the depth. This makes slicing intuitive but also very powerful. Now, there is another function, access, using which you can slice directly across one index level. So if we want to extract all rows for the East region, we will write grouped dot access and within its brackets we'll write East, comma, and we'll write level equals to within single quotes we'll write region. Okay. If we run this code, we are going to get the loan amounts for the East region for all the years. So using access, we accessed the data at the region level. Now, if we want to extract all rows for the year 2022, then we can write grouped dot access, and within its brackets we'll write 2022 comma, and this time the level will be E. If we run this code block, there you go. We have just extracted all the rows for the year 2022 across different regions. All right, clean, readable, and efficient. Now, if you want to pivot the inner index, let's say region here to appear as columns, then Pandas provides an unstack method for that. It is very handy for comparisons. So let's check that. So what we are going to do, we are going to first print grouped over here. Let's do that. All right. This is our grouped data frame, which we printed earlier. No change in that. We will create a new data frame, which we are going to call unstacked. And after the equals to sign, we'll write grouped dot unstack. And within brackets, we'll write region. Okay. Because we want to pivot it. That's why we are writing region over here. And we are going to now print this unstacked data frame. Let's execute this code block. And there you go. You can see that the region appears as columns now. Okay. East and west are appearing as columns. And within these columns, there are loan amounts for the years 2022 and 2023. If you now want this reverted, that means you want the region to go back as rows. Then there is a method to undo this as well, and it is called stack. So let's create a new data frame which we are going to call restacked, and after the equals to sign we'll write unstacked, which is our this data frame dot stack. All right, and we have to revert the region column, so we'll write region comma, and as its second parameter we'll write future underscore stack equals to true. All right, we'll print this restacked data frame now. Let's execute this code block, and there you go. Our data frame is back. The second parameter in the stack function is to suppress a warning that says stack function will be removed in the future version of Pandas. So before using this function in your project, you must refer to the Pandas documentation for an alternative. Now, in my grouped data frame, if you see, I have region appearing before the year. If there arises a need to flip the hierarchy, how would we do it? So Pandas provides a function for the same, and its name is swap level. So we create a new data frame which we call swapped, and after the equals to sign we write grouped dot swap level. All right, and we print this new data frame. Let's execute this code block, and there you go. Region appears after year now. Okay, so the hierarchy is reversed. It is recommended to sort multi-indexes during complex operations. It helps pandas work faster and ensures consistent output. So we use sort underscore index function to do that. So we create a new data frame now, which we call sorted underscore grouped. And after the equals to sign, we'll write grouped dot sort underscore index. And within its brackets, we write level equals to, within single quotes, we write here. Now let's print the sorted grouped data frame first and execute this code block. There you go. You see that this data frame is sorted by the index year. Rows for 2022 appear first and then rows for 2023. Now in our group data frame, the indexes are easily visible because it's a short data frame. But let's say we have a wide data frame in which there are multiple indexes and we want to find out the names of each of those indexes. To do that, we can write grouped, that means the name of the data frame, dot index dot names. We can use the names property, and this will give you the indexes which are there. And now to access their values, we can use another function called get underscore level underscore values. So let's check that as well. So we'll write grouped dot index dot get underscore level underscore, I'm sorry, it's going to be values. Within its brackets, we'll write region. All right. So let's run this code block, and there you go. We have got all the values for this index region. Now let's revisit our main data frame, which is df. So let's first print it. So I'll write df and execute this code block. Okay. This is my data frame. Now earlier we set the indexes using groupby. Now if we want to manually set indexes on this data frame without using groupby, then how can we do it? We can use the set underscore index function to set indexes on this data frame. We can pass one column or a list of columns to the set underscore index function to create multi-level indexes. So let's create another data frame which we are going to call df underscore multi. And after the equals to sign, we write df dot set underscore index. And within its brackets, we are going to pass a list of columns which will be region and year again. Okay. And of course, we are going to print this df underscore multi column. Now let's execute this code block. And there you go. Region and year are now appearing as indexes. Earlier we did the aggregation, that's why we were getting only 4 rows, but this time we haven't done any kind of aggregation. So the indexes have been set on the entire data frame. If you want to remove these indexes, then we can simply use the reset underscore index function. So let's create another data frame, which we are going to call reset underscore df. And after the equals to sign, we'll write df underscore multi dot reset underscore index. Let's print the reset underscore df as well. And let's execute this. All right, we have got our data frame back. The indexes have been eliminated and they now appear as regular columns. Earlier, I told you that when we grouped by region and year, Pandas created a multi-index for us automatically. Region and year became the index levels. That's the default behavior. But what if we don't want them to be indexes? When we do groupby, we can achieve that by using a second parameter in the groupby function known as underscore index and set it to false. So we write df dot group by, and within its brackets we are going to of course pass a list of columns and they will be region and year. All right. And after this, as its second parameter, we are going to pass as underscore index and its value we are going to set as false. Okay. Now after this, we are going to do the aggregation using the add function. So within its brackets, we'll again use curly brackets, and within single quotes, we'll write loan underscore amount colon. Within single quotes, we'll write sum. I think I have made a mistake. Oh. Instead of comma, I have placed a full stop over here. Let me correct that and let me execute this code block. And there you go. It gives us SQL style output where groups of region and year appear with loan amount or the sum of loan amount alongside them. Okay. You can now use region and year as multi-indexes on this data frame. So this was multi-level indexing in Pandas. Indexes help in complex data analysis and data operations and are very important and super useful. So with this, we have come to the end of this video. Don't forget to check out my full Pandas course playlist, which you can find on my channel or in the description box of this video or in the I button. And subscribe to my channel if you haven't already. I will see you in the next video. Till then, goodbye and take very good care of yourself.